Good day, mathletes. So we're still in section 2.2, and we're going to talk about infinite limits today. So what happens when, we've been in situations where graphs kind of approach a certain value and just kind of level off, right? Where it gets to like, let's say 3.9 and then 3.99 and 3.999, and our outputs get super close to a value, but they don't, and they keep getting closer and closer to that value, but they don't increase forever, right? They kind of have a bound, right? A boundary, or a limit, if you will, right? But what happens if we have boundless limits? What happens if they keep going up and up and up and up, and they don't approach a certain number, but they just go on forever? So that's what we're going to see today. All right. So just a real quick review from last time. So remember we talked about one-sided limits. Remember that that little minus there means approaching a value from the left, and then the plus means approaching a value from the right. Okay, and remember also that that the two-sided limit, right, exists, or exists and is equal to exists when the limit from the left is equal to the limit from the right, right? When they're both equal to the same value, in this case L, and then the two-sided limit will be equal to that same value, right? So the two-sided limit only exists when the limit is the same from both sides, and the limit will equal whatever that value is, right? Okay, and that holds true with infinite limits as well. Okay, so let's talk about infinite limits. So an infinite limit is when we have a limit that approaches infinity, okay, or really something without a limit, actually, right? Where it goes up forever, or in the case of negative infinity, goes down forever, okay? So if we talk about infinite limits from the left, we're saying the values increase without bound, right? They go up forever. They'll keep going up and up and up and up, right? And it might go super rapidly. It might go up rapidly, up and up, or it might go up, by a small rate, up and up. But either way, if it doesn't have a boundary, then it approaches infinity. Okay, and so what you would do is you just put the limit from the left equals positive infinity. And you don't have to necessarily put the positive. You can just put infinity, and that's fine too. Okay. All right. Now, if we have limits that instead of going up without bound, they go down without bound. If they decrease without bound, then you put negative infinity as your result. Okay. So the limit as x approaches a from the left of f of x would be negative infinity. Okay, so if they keep getting more and more negative, then they don't, there's no boundary, there's no leveling off, then that'll be negative infinity. Okay, same thing from the right. So you can have values that increase without a bound as x approaches a certain number from the right, and that means the limit will approach positive infinity. And the same thing if they decrease without bound, coming from the right, then that would be negative infinity. Okay. All right. So then, of course, the two-sided limit, like we just talked about, right? If the limit's the same on both sides, so if it goes up on both sides, if as x approaches a from the left and the right, if they're both approach positive infinity, then the two-sided limit is positive infinity. Okay. If both sides decrease without bound, if they both approach negative infinity and go down forever, then the two-sided limit will be negative infinity. Okay. And of course, we know if they don't match, right? If the limit from the left doesn't match the limit from the right, that means the two-sided limit doesn't exist, right? Okay, so let's see. So let's take a look at this example here. It says evaluate each of the following limits. If possible, use a table of functional values to confirm your conclusion. Okay. So let's see. So part A, we're looking at finding the limit of 1 over x as x approaches 0 from the left, okay? So let's just think of this intuitively for a second. If these numbers approach 0 from the left, think about what numbers approach 0, like negative, from the left would be on the negative side of 0, right? So it would be like negative 0.1, negative 0.01, negative 0.001. So they're going to get smaller and smaller, but negative, right? If we do 1 divided by a number, if we do 1 divided by a number, and that number is a fraction, and it gets smaller and smaller, 1 divided by those numbers are going to get bigger and bigger, right? Because if we're flipping over these fractions that are really small, they're going to turn into really big numbers, okay? And we'll see that when we do the table. So let's go ahead and make a table here. All right, so I set up these tables here. So now if we're approaching from the left, like I said, we're going to do negative 0.1, then we'll get a little closer to 0, negative 0.01, negative 0.001, negative 0.0001, right? And we'll kind of just see the pattern. We maybe, we may not need to get to this last one. All right, so remember, if I do 1 over x, if I put this in for x, so this would be negative, or 1 over negative 0.1, right? And so 1 divided by a tenth, right, is basically what that is. 1 divided by a tenth would be 1 times 10 over 1, right? We multiply by the reciprocal. And so you can try this on your calculator, but it comes out to negative 10, okay? Then the next one we're going to do negative 1 divided by negative 0.01. So 1 divided by 100, a hundredth is going to be 100, but it'll be a negative, right? A positive divided by a negative is a negative. And you can see the pattern here, right? If I divide by 1,000th, I'll get 1,000. So if I divide by a negative 1,000th, I'll get a negative 1,000. And so forth, right? There's going to be negative 10,000. There's going to be negative 100,000. So what's happening is it's getting more and more negative without boundary, right? It's not going to level off. It's going to keep, we're just going to add a 0 over and over again, right? It's going to be negative 1 million next, and then make negative 10 million, negative 100 million, etc. So it has a boundless, limit, right? It keeps going and going. And so this would approach negative infinity, right? It's never going to stop getting negative, okay? Or more and more negative. All right. So, and that's a little bit of a misnomer more, because negative is kind of a Boolean value. It's yes or no, right? So anyway, yeah. So more and more negative is a little bit of a misnomer, but it's going left and left on a number line. I guess we could say more and more left on the number line. All right. Now part B is going to be a similar thing. We're approaching 0 from the right, so we're going to get closer and closer to 0 on the positive side this time, right? So I'm going to start with 0.1, and then 0.01, 0.001, and so forth and so on, right? And you probably already figured out what's going to happen here, right? Because it's very similar to the other side, except it's going to be positive. So if I do 1 over 0.1, I'm going to get 10. If I do 1 over 0.01, I'm going to get 100. All right, and so forth and so on. So then 1,000, and then 10,000, 100,000, and this will just keep going up and up forever, right? And so that means this is going to approach positive infinity. All right. So we found the limit from the left is negative infinity. The limit from the right is positive infinity. And so that means our overall limit is going to be, if they're different, that means it's going to be DNE, right? Does not exist. And so we can write it like that, right? Or you can write the letters D and E, either way. All right. So that's how we, that's what it looks like when we have an infinite limit, is that limits will increase or decrease without bound, right? As we approach whatever value this is, right, from whatever side. So as we get closer and closer to that value from either side, we're either they're gonna go down forever, or they're going to go up forever, right? as we get closer and closer to those values. All right, and just one more tie-in. So remember that our inputs are getting closer and closer to this value, and what we're determining is what happens to our outputs, right? So our outputs approach negative infinity as we get closer and closer to zero from the left, and our outputs here approach positive infinity as we get closer and closer to zero from the right over here, okay?